Jean regularly takes a break from work to go to the post office. Okay, the amount of time Jean waits in the queue, that means line, to be served at the post office has a continuous uniform distribution. That means this is a continuous uniform distribution question, and it is between 0 to 10. So 0 to 10, that means the distribution is going to be A to B. So that's how it's going to be. So let's write this down first. So we have to write the distribution. It is going to be 0 to 10. Let's write this down first, and we have to find the expected value, that means mean and variance. Now the formula for mean and variance is this: if you have a distribution from A to B, then the expected value is A plus B by 2, and the variance is B minus A whole squared divided by 12. Now you have to be a bit careful about using the random variable, because sometimes the random variable changes. In that case, it's best to use the letter mu and sigma squared. So let's continue. So what we have to do over here, so the expected value or the mean is going to be A plus B divided by 2, which is 10 by 2, 5. And the variance, which is sigma squared, is b minus a, which is 10 minus 0 whole square divided by 12, so which is 100 divided by 12. And if we simplify this, this is going to be, so it turns out to be 25 by 3. So this is going to be 25 by 3. Question number B says, find the probability that Jean, or Ja in French, does not have to wait more than 2 minutes. So remember the story. It's a good idea to read the story very carefully. The story is that you have to wait from 0 to 10 minutes. That means you have to wait within 10 minutes before you get served at the post office. And the story has a context that you're taking a break from your work and going to the post office. So what we have to do over here is we don't want to not have to wait more than 2 minutes. This really means you have to wait either 2 minutes or less than 2 minutes. That's what it means. So it means the probability of x, we haven't defined it x, but let's use the letter x. X is less than or equal to 2. That's what it means. If you don't have to, if you don't want to wait more than 2 minutes, it means you either have to wait 2 minutes or less than 2 minutes. Now remember one thing, what this is. This is a continuous distribution. That means it can have any value. So if you have a value that something is less than something, it is the same as something being less than or equal to. It simply does not matter whether we use the equal sign over here, because it is discrete. So what we do, we can just write x is less than 2. Here it doesn't matter. So the first thing we have to do for finding probability, always use this step. We have to draw a diagram, which is a rectangular distribution diagram. So it is from 0 to 10. So that turns out to be, this probability is going to be 1 by b minus a. That means 1 by 10. So remember, if you have an interval like this, then if you have an interval like this, then you have to find the PDF. Then the PDF would be 1 by b minus a. So in this particular case, 1 by b minus a is 1 by 10. So the probability has to be 2 or less than 2. So if this is 2, so the less than 2 is the rectangle. So from 0 to 2, the length is 2, and the breadth of the rectangle is 1 by 10. So the probability is going to be 1 by 5. Question number C. Question number C says, Jean visits the post office 5 times. So you have to go there 5 times. You go there first time and you go there second time. So it could be you go there Sunday, Monday, Tuesday, Wednesday, Thursday. So that means you go one day and you go the next day and you go the next day. So they said find the probability that she never has to wait more than 2. That means the probability of not having to wait more than 2 is 1 by 5. And going there 5 times, we have to use the concept from the first paper S1, where we know the AND rule. The AND rule, where we know if something is happening, then another thing is happening, and the AND rule means the product rule. We have to multiply. So here what we have to do is the required probability. We can just write required probability is 1 by 5 and 1 by 5 and for 5 days 1 by 5 and 1 by 5 and 1 by 5. So, or we can simply write 1 by 5 to the power 5, and this turns out to be 0.00032. So this would be 0.00032. That's the probability. So the final one is a bit different. The question is, now you always have to read the story carefully to understand what's going on. So Jean is in the queue, that means line, when she receives a message that she must return to work. So this is the story that we are doing for this sum. So this is something that was given at the first. Jean regularly takes a break from work. Now it is known that she has to go back. She can only wait in the line for a further 3 minutes. That means she can only, she has 3 minutes in her hand. Given that she has already been in line for 8 minutes. So that makes a total of 5 minutes and 3 minutes is 8 minutes. So she's already in line for 5 minutes and she got a message that she has to leave within 3 minutes. That means she can be there maximum of 8 minutes. That's how much time she can spend there. So the question is, find the probability that she must leave the post office without being served. If she has to leave the post office without being served, it means she has to be there more than 8 minutes if she wants to be served. So the probability that we have to find basically is that she has to wait in line for more than 8 minutes, because if it was 8 minutes or less than 8 minutes, she would be served. So in this particular case, so we have to find the probabilities. Let's do this again. So this is going to be probability of x is greater than 8. It doesn't matter whether we give equal to sign because this is continuous distribution. So let's draw the distribution again. It's from 0 to 10. And this is 1 by 10. So more than 8 means if it is here, so it would be this one. So from 8 to 10, it is 2 because probability is area, so length into breadth. And this is 1 by 10, so this would be 1 by 5. So the probability of being served, if you have to wait for more than 8 minutes, the probability is 1 by 5. Now, this is not the final question because you have to remember this. Given she has already been in line for 5 minutes, that means given that she has been waiting for 5 minutes. So again we need a concept of S1 where it says conditional probability. Conditional probability states that if a condition is given, for example, find the probability that event A occurs given, that's the notation for given, that event B also occurs. So the notation for that is we have to divide the probability with B, and whatever probability we have over here, it is going to be an intersection. That means both this and this happens given that this happens. So basically rule of thumb is if any information is given, you have to divide it. So since an information is given, so this information says the person has already been in line for 5 minutes. That means the person hasn't been served. That simply means the person will take more than 5 minutes to be served. And that probability turns out to be x is greater than 5. So if we use this, so greater than 5, that means 5 to 10, the length is 5 and the breadth is 1 by 10. So this will be 1 by 2. Hence, the required probability would be find the probability that the person will take more than 8 minutes to be served. So that is 1 by 5. Given the person has been standing in line for 5 minutes and still not being served. So that is 1 by 2. So the probability is going to be 1 by 5 divided by 1 by 2 is 2 by 5. It might appear that it is 1 by 10. But be careful of that. So this particular question had two parts that basically use the concept of previous basic S1 probability rules. We have another question that deals with continuous distribution. It's question number 7. So the first thing that we have to do, we have to show that the constant k is 1 by 5. So remember the rule for finding constant. What we have to do is we know the total probability, which is if you have an overall limit, the limit here is broken down into two. The limit is basically from 0 to 2, and it has been broken down by two expressions, one for 0 to 1 and the other for 1 to 2. So the basic idea for finding a constant, if you have the total limit, suppose from x1 to x2, and if you integrate the PDF, the function of probability, that would give you the total probability, which is 1. So that's how we find a constant. That's the rule for finding the constant. But since here the limit has been broken down into two expressions, we have to do this by breaking it down into two expressions. First one is 0 to 1, and the expression fx is half x dx. We add this to the probability of 1 to 2, and the PDF is kx cubed dx, and these two combined would give us the total probability of 1. So let's do this. If we integrate this, half is half, x is integrated to x squared by 2, and the limit is 0 to 1, plus k is the constant k, and x cubed is x to the power 4 by 4, and the limit is 1 to 2. So what we have over here is 1 by 4. If you put the limit 1 square minus 0 of x is 0, the whole thing is going to be 0, plus if you put the limit over here as 2, this would be k 2 to the power 4 by 4, minus if we put the limit 1, k 1 to the power 4 by 4 equals to 1. This turns out to be 1 by 4 plus 2 to the power 4 is 16. 16 divided by 4 is 4. So 4k minus k by 4 equals to 1. So this turns out to be 4 minus k by 4 is going to be 4 4 is 16. 16 minus 1 is 15 k by 4. And on the other side it would be 1 minus 1 by 4, which turns out to be 3 by 4. When we do cross multiplication, so k equals to this 4 and this 4 cancels. So 3 divided by 15, which is 1 by 5. And that's exactly what they asked us to show. Calculate the mean. Now remember, the rule for the mean is expected value is overall limit x1 to x2, but this time it has to be x fx dx. That's how we find the mean. But here, since the limit is broken down into two parts, so we have to separately find it and add up to find the mean. So what we have to do, so let me write it over here. Question number B. Expected value equals to limit. The first limit is 0 to 1. So x fx is half x, dx plus 1 to 2 x fx. Fx is k. K is now 1 by 5, we already know. X cubed dx. This would give us the expected value. So it's better to do it separately to prevent any mistake. So for 0 to 1, half x squared dx. I multiplied the x with the x. This turns out to be half x to the power 3 by 3. 0 to 1, which turns out to be 1 by 6. 1 cubed minus 0. So this would be 1 by 6. Now next, let me do it over here since I have a little bit space over here. 1 to 2, 1 by 5 x to the power 4 dx, and this turns out to be 1 by 5 x to the power 5 by 5. 1 to 2 is the limit, so this would be 1 by 25. 2 to the power 5 minus 1 by 25, 1 to the power 5, which is 1. This would be 2 to the power 5 is 32 by 25 minus 1 by 25, which is 31 by 25. Hence, the expected value. So the expected value is going to be 1 by 6 plus 31 by 25, which is 211 by 150, and this is the same as 1.4067. 1.4067. The next question, we have to find the cumulative distribution function, or CDF, and it is 7 marks. So well, again we have two portions, so we will have two expressions for CDFs. So the first one is going to be, this is the rule for finding the CDF. CDF is cumulative, that means integration of fx. But since it's an expression, it would not have any limit. So instead, it will have a plus c because it is indefinite integral. Now, plus c is a constant. So in order to find the constant, this is the rule. If we use f lower limit, suppose the lower limit is x1, then fx1 would be 0. And if we use the upper limit, which is suppose fx2, the upper limit is 1. That means total probability, since CDF is cumulative and total probability added up is 1. Now notice this, when we talk about the limit is from 0 to 2. Remember that, 0 to 2, that means this is the overall limit. So the lower limit would be 0 and the upper limit would be 2. This 0 and 1, these are not the limits, remember that. So let's continue. So let me do it over here. So the first one is going to be, so the CDF for 0 to 1, this is going to be, expression is fx, so this is half x dx. So this would be half x squared by 2 plus c. So this would be 1 by 4 x squared plus c. Now we have to find the constant. Remember, the lower limit is 0. 1 is not the upper limit, 2 is the upper limit. So we have to use the lower limit. So f lower limit equals to 0. So we can write 1 by 4 0 squared plus c equal to 0. Therefore, c equals to 0. We found the expression. The first expression for CDF is 1 by 4x squared. Then the second expression. So fx equals to, the second expression is k, which is 1 by 5 x cubed dx. And this turns out to be 1 by 5 x to the power 4 by 4 plus c, again constant. So this will be 1 by 20 x to the power 4 plus c. Now remember, now we have the upper limit. So f upper limit, the upper limit is really 2. So f upper limit, total probability is 1. Therefore 1 by 20, 2 to the power 4 plus c equals to 1. 2 to the power 4 is 16. 16 by 20 plus c equals to 1. And c equals to 1 minus 16 by 20 is 4 4s are 16, 4 4 5s are 20. So this is going to be 1 by 5. 5 1s are 5 minus 4 is 1 by 5. So c is 1 by 5. Therefore we can write fx equals to 1 by 20 x to the power 4 plus 1 by 5. Now you have to define the expression. In order to define the expression, so what we have to do is this: fx equals to expression, comma, the limit. The limit is the same as the PDF or small fx. So if it's between x1 to x2, just it will be exactly the same. But here you have to write 0, which is less than the lower limit. And here you have to write 1, which is greater than the upper limit. So the expression has to be defined specifically. It would be hence fx equals to, since the expression is now broken into two parts, the first part is going to be 1 by 4 x squared, comma, and the limit would be the same as before, and the second expression will be 1 by 20 x to the power 4 plus 1 by 5, comma, and we will write the limit as it is in the question. So let's see what's in the question. The first one is 0 to 1, so we will write here 0 to 1. The second one is 1 to 2, so we will write here 1 to 2, and this will be 0 and this will be 1, and this will be less than the lower limit and greater than the upper limit. This is how we specify the CDF. Now the question related to CDF is the median. Question number D is finding the median. Now the rule for median is fx equals to 0.5, meaning 50%. Median means half of the data has a probability of something less than, and other half is something more than the median. So 50%. So fx is cumulative, that means 50%. So what we have to do over here, we have to find the median from both the expression and see which one holds true for the limit. So what we can do is take the first expression, first CDF as the median, and find the value of x, and then take the second expression and see which one is the median. So let's do this. So question number D, so taking the first expression, so for fx equals to 0.5, if we take the first expression, it turns out to be 1 by 4 x squared equals to 0.5. That is, x squared equals to 2. If you multiply 0.5 with 4, that means x equals to plus minus square root of 2. Now for fx is 0.5 for the second expression, we get 1 by 20 x to the power 4 plus 1 by 5 equals to 0.5. And that turns out to be 1 by 20 x to the power 4 equals to 0.5 minus 1 by 5, which turns out to be 0.3. So this is 0.3. So x to the power 4 equals to 0.3 into 20 is going to be 6. So now what we have over here, remember, since it's an even number, it will be plus minus 4 root of 6. So let's see which one is more valid. So 4 root of 6, that means 4 root 6, 1.565, 1.565, and the other one, square root of 2, that is 1.41. Now in order to decide which one to take, we would go with the one that is a bit greater, which is higher. So that means we're going with 1.567. So we can write, since this is plus minus from the limit 0 to 2, the answer is median is 1.565. Now the final question is again a question from S1. Comment on the skewness. Remember, whenever you want to find the skewness, you want to compare the mean with the median. If the mean is more than the median, it's positively skewed, otherwise it's negatively skewed. So let's write down the value of mean and median side by side. Now the mean is 1.4 and the median is 1.5. If it was 1.41, that would also be more, and this is also more. So what we can write here in question number E, mean equals to 1.4, median equals to 1.57. Since median is less than mean, it is positively skewed.